So I'm doing work on computer translation of text between languages. So if you've been to Google Translate or freetranslation.com or something like that, you've had experience with this field called machine translation. And I try to improve the accuracy of these computer translations by specifically focusing on the order of words in the translation output.
Basically, I improved body armor for soldiers. And I took a ceramic and reinforced the weak backside of the plate with different types of composites. And those are just other kinds of materials. And I found that if you use Kevlar, you can increase the armor's strength by about 19,000%.
But why would you want to shrink a computer down or make it faster? Clearly, beyond just making new laptop computers or whatever, there's all sorts of applications you could have for that. Embedded in clothing to have intelligent clothing that responds to temperature. You could have it in a biological implant, so, for example, an insulin pump embedded into the body for a diabetic. But in all these cases, you need to have computers that can interact on the atomic and molecular level. But to be able to design things like that, there's some mathematical models that are basically far too complex at the moment to really be effective and efficient and cost effective. So basically, my project was to try to work on those mathematical models and simplify them so that hopefully one day scientists and engineers can take my results and custom design materials to make the small and fast computers that you can embed in all sorts of applications.
I mean, it's really vital for communication because there are so many different languages throughout the world. And oftentimes if documents need to be translated, they can having humans translate these documents, especially if there are really large amounts of them, can be incredibly expensive and incredibly time-consuming. So computers offer the opportunity to, for a relatively low cost, to translate large amounts of text. And that can really aid people in communication. And also, for example, soldiers located around the world, actually currently in Iraq, make use of these computer translation systems to help them speak with locals where they are deployed.
Well, I built a robot that navigates through hallways and searches for people. So basically, if there is a hazardous waste problem, or if there's toxins, or a bomb scare, or something like that in a building, the robot can go in and autonomously search for people. So you can just let it go and it'll navigate around and then come back and give you coordinates of people that it's found.
Actually, the Marines have copies of my first and second year's research. So I'm kind of hoping to look at the real-world applications of it, and it did come out just recently, probably about maybe a year ago, that this is the technology that Ceradyne just implemented into the newest interceptor armor systems. So it's kind of already in place to keep moving forward.
There's a lot of future work that needs to be done on the project to make it marketable. So right now it works in pretty simple situations, but definitely like extra steps to make it more accurate and to make it work in more difficult situations and react to more realistic, unpredictable environments. Then if that all gets done, which I hope to work on soon, then I would like to definitely try to market it to someone.